these basic polygons, and we're going to be demonstrating what the area is for any one of these types of figures. So we'll start off with the triangle. So if you look at a triangle, right, what you can do is you can draw the rectangle around it. If I could draw that, which I can. Okay, so so I'll draw a rectangle. So if you take a rectangle and you draw it like this, right, so that way it's a perfect rectangle, and we should be able to intuitively justify that if this length is h, then this length is for sure h, and we know that the area of this rectangle, this entire purple rectangle, so this, everything in here, right, so area of the purple rectangle, right, area of purple rectangle, right, we should be able to convince ourselves is just base times height, right, or just b times h, where this is the length and then this is the width, or whatever, vice versa. Okay, and with that, okay, what we then should be able to see is that, well, let's break up this rectangle further. Let's find out what base times height exactly is. So let's look at this left-hand blue rectangle over here. So if we look at the blue rectangle, we should see that the blue rectangle plus this, I don't know, green rectangle, right, is equal to the area of the purple rectangle again. So that's going to be equal to base times height as well. So let's just call this rectangle 1, or area of rectangle 1, area of blue rectangle, or rectangle 1, let's call it just to make it easy, plus area of rectangle 2, which is that green one, is equal to base times height as well, right? This area, this blue area, plus the green area is for sure the area of the entire rectangle. Now let's break this down further, and let's say the area of rectangle 1, if you're looking at it, you should be able to see that this triangle, this pink part right here, right, well, this pink part is exactly half of the entire area of rectangle 1. So the area of rectangle 1 is 2 times the area of, I don't know, whatever you want to call it. Let's call it triangle 1, right? Because this is triangle 1, this pink one. Plus, right? And I'll do this. So plus, if you look at this yellow triangle right here, right, it's exactly half of the area of rectangle 2. So 2 times the area of the triangle 2, you should see, is the area of rectangle 2. And again, this all equals base times height. Now, if you look at this left-hand expression, it's 2 times the area of triangle 1 plus 2 times the area of triangle 2. Now we can factor out a 2. You should be able to know how to factor, right? 2x, let's just do a little factoring on the side. 2x plus 2y, right? What can you factor from both of this? You can factor out a 2 to get 2 times x plus y, right? That's just basic factoring. So here I have 2 times x plus 2 times y. I can factor out a 2, and I'm left with the area of triangle 1 plus the area of triangle 2 equals base times height. And if we look at the area of triangle 1, which is this pink triangle right here, plus the area of triangle 2, that's the area of our original triangle. We want that area. So this inside part we should see as area of our triangle, which is what we actually care about. So 2 times the area of what we care about is equal to base times height. I divide by 2, and I get that the area of the triangle A equals base times height divided by 2. And it's important to see that, again, I divided by 2 on both sides, right? When I divide by 2 on both sides, I get the area of the triangle that I want, which was this triangle that I'm outlining in yellow. It's important to see that this is for any triangle, right? We could have done this technique for any triangle, okay? Okay, now that's for a triangle. We have that justified. Now let's justify the area of a parallelogram, okay? This one's a little bit easier. I mean, the only thing we would need to really convince ourselves of is what we can do here. So what I can do here is I can pick out this triangle right here. And I can pick out this triangle right here and just move it over to right here. So when I take out this triangle and move it over and glue it right onto here, what I construct is a rectangle. So I took out this triangle over here and I just moved it right over to here. So I have this new rectangle right here. Okay, I have this rectangle like this. And we should see that the base stays the same. This length right here is the same as this length, right? So I just move that length, so this base is the same, it's just B. And now it's just this rectangle right here. And the area of this rectangle is going to be equal to the area of the parallelogram. So the area of a parallelogram is just base times height. Okay? And that's the way we could justify the area of a parallelogram. You could just move it over. You could just say that the areas of the two figures when we move this over is the same. And again, this could be done for any parallelogram. The area of a trapezoid. The area of a trapezoid is going to be the little bit more tricky one. You want to duplicate this exact trapezoid and you want to flip it upside down. So that way it looks something like this. Okay, where this is base 1 and then this is base 2. Now, if you move these two trapezoids together, what you will construct is a parallelogram. And you could prove that to yourself in a few ways. I'm pretty sure I'm not going to go through it right now because we should just convince ourselves that it's true. It's just to show that the formulas for area are not arbitrary. Okay, so here's your two trapezoids. This is one trapezoid, this is your other trapezoid, and then combined they form this parallelogram where this is base 1, this is base 2, and then this is base 2, and then this is base 1, and h, of course, stays the same. So this is h, right? And we just saw that the area of this parallelogram is this entire length, right? So if I went back over here and I just drew the parallelogram, the original one, this is the base, right? But now that length is just B1 plus B2. So the area of this figure is B1 plus B2, because that's this length, right? Which is the length that I was originally talking about in that other parallelogram. And now I have this as my height, because that's the area of a parallelogram. Now, this parallelogram we should be able to see is exactly twice the area of one of these trapezoids, because I constructed this parallelogram by duplicating this trapezoid and then flipping it upside down and then joining it with the original one, so it's exactly twice the area of the trapezoid that I care about. So my last step in this is just to divide. If I want the area of the trapezoid, to divide by 2. And then this is the area for a trapezoid.